This video we are further looking at our algorithm of differentiation. So we are considering direct differentiation, and we can begin with some kind of examples. So if I have differentiate ax, you're there. If I'm to differentiate ax, it means that it is the d. If I can let maybe y that is equal to x, I was going it direct, such that the dy dx will equal to the d dx of ax. But we see that the principle says lower down the power, reduce it by 1, meaning this is a 1 times a, which is a, x power 1 minus 1, which is x power 0. Using indices, I got simply a. So more, if this one is 1, more general differentiation can be of a x power anything I can call n. You are there, such that if I let y to equal to a x power n, my differentiating y with respect to x, this is the same as the d dx of a x power n. But the principle says lower down the power, meaning have here a n x power n minus 1. This is one of the general principles of direct differentiation. So we have here another simple number, that you find the gradient function of y is equal to 5x squared. I know that maybe as a part of our solution, my y is equal to 5x squared minus 3x. The gradient function is the dy dx. So my dy dx is equal to, so I differentiate each term independently. So if I differentiate this guy, I lower down 2, I have here 10, x2 minus 1 is 1, minus a 3. That is my gradient function. So we have here another number, that you find the gradient of the curve y is equal to x squared at the point 3, 8. At 3, 8. So as our part of the solution, we have that y that is equal to x squared. If y is equal to x squared, I need the gradient function first. So dy dx, lower down the power to reduce it by 1. So it is as simple as that. So at the point at 3, 8, at 3, 8, the x component is a 3, meaning my dy dx is equal to 2 multiplied by 3, such that my dy dx, which is the gradient, is equal to a 6. Stuff is as interesting as that. So we have another very simple question here, that you find the gradient of the point. Find the gradient of the point on the curve y is equal to x squared, whose gradient is 8. A very simple one. So as part of our solution, we have that y is equal to x squared. I first get the gradient. You're there because they've given me the value of the gradient. So it means that my dy dx, I differentiate this guy, is equal to 2x, but I've been told gradient, but dy dx is equal to the gradient, right, which is equal to 8, meaning that my 2x is equal to 8. I need the coordinate of the point, divide through my x is equal to a 4. But then I know that my y is equal to x squared, meaning my y is equal to 4 squared, which is a 16. I've not been asked x and y, but I need the coordinate. So therefore the coordinate of the point is simply a 4 with a 16. Hope you people are seeing the flow of how mathematics is simple. Yeah, so basically that's all about our direct differentiation. It is as simple as that. So in our next video, I don't want to make them very long, you guys can get bored. Yeah, so in our next video, let us look at tangents and normals. Let us look at tangents and normals.